presentation from Dom, then one from me. And yeah, Dom, go ahead. You should be able to share your screen. Let me know if you can't.
Sure. Let's see. Perfect.
I'm going to start a practice of just asking people to send me their slides if they have any, and I'll store them in the drive, or maybe Taylor will. I think we haven't been good about that, but people have wanted to return.
Yeah. All right. Can everyone see that, right? So, hey, everyone, I'll talk about a little bit about the work that I've been doing. So a lot of it has been doing pressure measurements and then also relating that to predictions based on some modeling that I've done. So I'll start out just with like a little outline of ultimate goal, and then kind of some of the tools that I've been using, and then the models and whatnot. So start out. So the ultimate goal is to be able to predict infiltration into the building envelope. And kind of the reason for developing this is there's yet to be a real model. So by real, I just mean there are equations out there to kind of govern the flow of air and kind of how it relates to the building envelope, but there's not really one really reliable unifying model that has the type of measurement ability to, or get the granularity of the time scale, and also just being able to relate it to a lot of homes in different regions. So that will be the ultimate goal. So looking at my own personal work, I have been looking a lot at pressure. So for most of you that know, air moves and wind is caused by air moving from high pressure to low pressure areas. And so relating that to the building envelope, we have two main natural causes of kind of pressure differences across the envelope. So we have the first one here is stack effect. And you see that one on the bottom right image. It's caused by temperature differences and density differences also. So if we consider like a winter scenario, we have the temperature outdoors will be lower and density will be higher than in an indoor environment. And so we'd see an attempt for the air to flow. If there is leakages, the air will flow from out in the bottom of the building, and we'd see a flow out at the top. So that would be our stack effect. We have an equation actually from developed by the Lawrence Berkeley National Lab here for that particular pressure difference by the stack effect. And you can see some variables. Some of the variables are just housing characteristics, kind of leakage areas and neutral levels, but some of them are also having to do with kind of the temperature difference also. The second natural pressure difference causing effect is the wind effect. So this one isn't kind of developed by a lab or anything. This one just comes from good old fluid dynamics. The Bernoulli equations just has to do with related to wind speed and the density. And so now I'll touch a little bit on some of the measurement tools I use to find these values. So we have our equations still here, but for the prediction, the model, I used a weather station. We have an image of the weather station here. It's by Tempest weather station on the top right. So using that, I was able to find kind of outdoor temperature, wind speed, also wind direction. I won't touch on that today, but wind direction and then the air density as well. Also a thermistor. We see that on the bottom right, little white node. That one is just for measuring indoor temperature, and using those relations, I was able to find kind of the temperature difference across the envelope. So for this measurement, I did not use a blower door. You see a blower door right in the middle, the big red square rectangle. I didn't use these measurements quite yet because these generally have to do with an individual home's leakage characteristics. And my main test case so far has been my apartment. So not to ignore my apartment mates, I haven't done those yet. But there are average values that you generally use for those, and so I was able to get a good average of what that should be. And ultimately, to validate the model that I've been using. We used a manometer that we have on the bottom left. And so, yeah, it has some ports. You plug some hoses into them and it'll measure across the building envelope pressure difference. And then we can relate that to what the model looks like as well. So without further ado, so here we have a little plot that I created of a data set. I think it's, yes, runs from overnight from the 13th to the 14th of November. So we see the predicted value in blue. So that's the output of what the model is saying. So that's with the equations that we just touched on. That is what ultimately the outcome is from those. And the red is what the manometer outputs. So just eyeballing it, you can see it does a pretty good job of capturing not only like just the magnitude of, I think almost entirely it's within about 1 Pascal of the validation, but it's also almost even better. It does a really good job of tracking the trend of the measurement. And so we see right up until about 8 or 9 p.m., we see almost a really good prediction of what the measurement, what the pressure is. And then after that, it gets a little over predicted. So I wanted to next touch a little bit of the contributions from the stack and the wind effect and see kind of what could be causing some of this over prediction, if this was due to the model or if this was just user setup not in a good area or something like that. So the next plot. So I was able to then break up the total prediction into its wind and stack components. Same thing. We see then green is the predicted measurement or predicted output that we had from the previous graph. In blue, we have the wind effect, and red, you can't really see it because it's almost overlaid by the total, but that is our stack effect. So we see right up until and a little after what would be sunset, we see a wind effect, but then after that, it drops to about 0. So that's about what we would expect. As some of us may know, the sun is what causes temperature and therefore pressure differences that drives wind. So after sunset, we would expect that the wind effect would essentially drop to 0. I was a little.
Allison's got a hand up. Can she ask a question?
Yes, go ahead.
You mind questions as you go? I don't.
Yeah, no problem. Go ahead.
Okay, this plot probably illustrates it less. If you go back one.
Yeah.
Only I don't work with Pascals as much actually. So is the differences between the teal and the reddish dot, like, because your scale is 1 to 3.5 Pascals, are those differences big? Do you think of them as big or small, or how do you think of them?
So it kind of depends, I suppose, on the leakiness of the home if we're relating it to flows. But in terms of pressure, Pascals is pretty small. I would say a couple of Pascals in the grand scheme of things is small, but yeah, if we're looking at a really leaky home, it could cause some flow that would be significant. But yeah,
Okay.
I wouldn't say it's super significant.
Thanks.
Mm-hmm.
And I would also say it relative to what, right?
Right.
So,
Right.
so if perhaps what we should think about is, would this cause a significant increase in flow that would cause our predictions to be off? And I think that's something we'll be experimenting with.
Right.
Okay.
Yeah, just so people know, common wintertime household pressure differences are just a couple of Pascals, 2 to 4 Pascals. So a 1/4 of a Pascal might be almost nothing in terms of pressure, like a single ply piece of tissue on your hand, but it's also could be like 10% of the entire driving force you have to have air coming into the house.
Mhm.
Mm-hmm.
That's
Yeah.
sort of-
One of the challenges of this project is we're dealing with very small pressure differences that could still be important.
okay.
Right.
Yeah, qualitatively, that's really helpful to hear, because that's what I was thinking, but I also I don't often look at Pascal plots. So I was like, I don't know, that seems small, but maybe it could be meaningful. So that's very
Mhm.
helpful.
Definitely. Yeah, so as we can see with the wind kind of gone, and looking back at this previous plot with that over prediction, I'm still kind of mulling over. I haven't figured out if this is because the model is a little skewed in terms of kind of putting more weight into the wind effect, or if this was just maybe a human error. Maybe I set up the kind of measurement tools a little off, but I don't quite have an answer as to kind of why this was a little over predicted. But as you said, small pressure differences can cause a difference. It just kind of depends. It depends on the characteristics of the house. And so,
Tom, did you say
Yes.
this was in your apartment?
yeah, so this is in my apartment, which also isn't the most ideal thing because there's only one exterior facing wall.
Right,
And so
right.
that's where I was measuring across. And so it's not the most ideal measurement kind of region, but yeah, it was in my apartment.
Okay. Because those equations are really intended for buildings that are open on all sides.
Mhm.
So I'm actually kind of shocked that the agreement is as good as it is.
That makes me feel a little bit better. But yeah, so we see that. So now I'll just talk a little bit on kind of what the next steps are. So obviously, just there's not too much more in terms of measuring of pressure and kind of developing those pressure models. It's just about streamlining kind of the implementation and what's the best way to go about implementing the measurement tools and processes and whatnot. So as you can see on the far right, we have an example. Tammy and Paul were gracious enough to let me set up one of the weather stations around their house. It's having a enjoyable snow day, I guess, there. So thank you to all the test houses, present and future. But yeah, so streamlining a lot of those measurement methods. And beyond that, it'll be now moving into actually measuring the flow. So rather than just measuring pressures, we'll be looking at another Lawrence Berkeley National Lab model. It has a lot of the same equations and kind of governing equations, but it has a little bit more to do with the building characteristics that I haven't done quite yet. So that'll be the next step in terms of that. And once we have that and we are able to calculate and model the flow, we'll be able to validate that against a little bit more reliable method in tracer gas. So I won't touch too much on that because I'll pass that over to Tammy now to explain about that a little bit more.
Yeah, thanks. Thanks, Don. Okay, awesome. Don, that was Don's first presentation as a grad student, so good job. And I'm going to give you folks a little context for how we're going to implement those measurements into Sapphires. So can you see my screen? So first of all, I'd say that those equations are implemented in some models like Contam, for example. What hasn't been done really well is them being validated. So you can put anything you want in a model, and then you can say these things should happen and you should get outdoor air inside, but it hasn't really been confirmed, especially on the hourly or sub-hourly time steps that matter for pollutant transport indoors and out. And so Don referred to a tracer gas measurement. This is what most people do. So in order to determine the air exchange rate of a home. And so I'll just give you a little introduction to this because this is something we're going to be doing. So a gas is released inside the house. That gas gets mixed into the air in a living space. And then that gas leaves the home as air leaks out and fresh air comes in. And it's the concentration inside the house is then proportional to the leakage rate and other things like the rate at which you release the gas. So what you can do is, knowing how much gas you release, you measure the concentration and you determine the leakage rate of the house. So this has been done many a time in houses. In order to use this technique, we need a gas that is harmless, that has no other sources in the home. There aren't many, but there are some. We need a frequent release of the gas. So you can do it either as a pulse, but if you want to measure over many conditions, then you have to do it, say, a pulse every hour, or you can do it continuously. You need continuous measurement of the gas. And so we have instruments that can do that, but they, because they're measuring at rather low concentrations, they tend to be bulky and expensive. And you need occupants who are not afraid of the gas and willing to put up with the equipment, which surprisingly is not many. So even though you know as a scientist that the gas is not harmful and it's safe to breathe, it's not always easy convincing people of that. Let me put a cylinder in your home and run this loud, expensive equipment. So the current state of the field is that if we want to understand pollutant transfer, we need to know that infiltration flow. And that flow is currently measured with tracer gas, which is expensive, labor intensive. It's hard to put in every home. That is the kind of the state of the field. When people say I've got an air exchange rate, Dominic referred to it as more reliable. I'm not sure it's 100% reliable, but it's kind of well known, people trust it. But as Dominic was saying, pressure difference across the envelope is what drives the infiltration flow. So why not just measure that pressure difference? Yes, you need to apply some somewhat additional equations to understand how much flow is going. You need to add the leakage area, but why not just measure pressure difference across the envelope, which is cheap, not as scary, and not as loud, not as expensive. So the answer is nobody has really done it. Sure, people have measured pressure differences across the envelope, but they haven't really used that to predict the flow. So if we were to just measure pressure difference and say, yeah, we can predict the flow because we measured the pressure, probably nobody would believe us, or they would argue about all the reasons that it could go wrong. So here's what we plan to do. And then this will lead to a discussion of Epic Homes with Ellison. So at first, the investigators who are required to put up with just about anything will measure delta P and tracer gas in their homes, starting with mine, and which has 2 exterior walls. And the purpose of that is to start with a well-known method, a well-accepted method, and show that delta P can be used to predict air infiltration. As Dom showed you, there are some things that are not perfectly predictive. Agreed that that model was not designed for an apartment. Apartments are actually some of the most complex airflow situations. So we'll start with something simple and gradually get a little more complex and show how delta P can be used. We expect to run into some mismatches. And then what do we do with those? So that's going to be part of the math that we're working on behind the scenes. But this is a small number of homes with very friendly occupants, showing that the delta P method works against a tested method. The next thing we're going to do, or this might go on in parallel, is work with Ellison's Epic Homes project. And there are already real-time indoor and outdoor measurements. These are not trivial to do and part of a whole other project. And so Ellison's project is supporting real-time measurements. We've seen that presented in these group meetings before. And what we would do as Sapphires is add delta P measurements. Then using some of the same equation, explore how well we're able to explain indoor-outdoor exchange. So these are our long duration measurements again, and instead of tracer gas, we'll look at the indoor-outdoor measurements of traditional pollutants that are already being made. And then shooting for our test homes in year 3 and 4, we're going to go into people's homes. We have to be ready. There's not going to be any playing around like, oh, we didn't do this quite right. So please let us stay another 3 weeks. So we have to be ready to go. And with that basis, we'll use Delta P in real-time indoor-outdoor measurements. And we'll use those to explain indoor-outdoor exchange, but also we're going to be doing some changes or interventions to the homes. And then we'll use this method to help explain why it's working or not working. So our ultimate goal is to be able to reliably use the Delta P method and understand it. And know what it might mean for infiltration. And we will do that with a sequence of intensive measurements in a few friendly homes, and then some homes that are in Fort Collins that don't require a lot of travel where we add Delta P. So I'm happy to take questions on that. And after that, the remainder of this discussion will be the logistics of including Delta P in Ellison's project. Hi, Merle. Hey. So does that sequence sort of make sense to everyone? Cool. Okay, and then Ellison presented on her Epic Homes project sometime last winter. And there was some statement like, hey, if you want to measure with these, you better tell me now. So that's the remainder of the conversation I'd like to have. Because now is sort of past. So we need to get on get working on that if it's going to happen.
I can jump in.
Yeah, go for it.
First of all, I really like your presentation, Don. I thought you did a nice job. Yeah. I've been excited to learn from you and see the results of the work that you've been putting in. So it's really neat to see that come together. And then Tammy, I appreciate the segue with linking what Dom's doing, putting it in context with the project. Always helpful to have those reminders. What comes to my mind first, actually, is what's special about Epic Homes seems to be that they are instrumented with indoor air quality measurements in multiple locations, indoors and outdoors. That seems to be their main value. As a reminder, since it's been, I think, since October, maybe, Epic Homes is a name of a program that the city of Fort Collins runs. They gave it that name. I'm not calling my project Epic. That's why I say that. I would never name my project Epic. That program name is actually pretty recent. What it seems to mean for the city of Fort Collins is meant to be more comprehensive than Efficiency Works Homes, which was a program that was focused on doing an energy audit, recommending energy efficiency measures that homes could then decide to act on and pay for themselves mostly. There's some access to financing that the city of Fort Collins offers, but they have expanded their vision of healthy and energy efficient housing so that Epic Homes program is sort of meant to be more comprehensive. Even as they keep their healthy homes programs separate, there's a lot more integration across those programs. And under that umbrella, we enrolled about 40 homes into a study where we put commercially available indoor air quality sensors that the city owns in a living room, a bedroom, and a kitchen, and then one outdoor measurement in their backyard, and then one measurement in the garage. Those homes, we are currently in the process of taking out the last 20, or now we're down to maybe 18 of those homes out of that study and completing it this spring. The city ended the project closed from the city's perspective when we reported out to Bloomberg Foundation last fall. And so we're trying to bring that to a close because there's a desire for some closure there. And what I'm wondering is that if what makes those homes worthwhile for the delta P measurements, could we put the same instruments in the test homes, the investigator test homes? That seems to answer or that seems to be the same as like what makes an epic home is that it has this richness of indoor air quality data and energy sensing. So we could even instrument the energy sensor in those homes as well. I think the one other piece that makes an epic home interesting is that it is occupied by people that are not thinking and acting on their indoor air quality or indoor environment any more or less than we think an average person would. So from a behavioral perspective, there might be some advantage to the households that we've worked with being, or households like those that we've worked with being test homes. But I think I just wanted to raise the question of if what makes those homes valuable is the instrumentation mostly, then I think we could put that instrumentation is coming offline. We could put that in really any home. And then the other feature that seems to be somewhat valuable is maybe that behaviorally there's some, you're not asking investigators to like pretend to be normal people, even though I think if you put instruments in people's homes for long enough, they're all going to be normal people.
So I guess, so maybe a really important question is there any chance to do the epic homes, or are you so close to coming offline that it's no longer possible?
So I don't think it's no longer possible. I'm just wondering what the trade-offs are about it being the homes that were in that study, because again, maybe to check my assumption, I don't know that any of the historical data matters, right? What matters is the concurrent data with the delta P measurement, right?
Sort of correct. So that to me, the value of the epic homes is that it's a wider range of homes with different building characteristics and operating conditions. And so, yeah, we could put the indoor and outdoor measurements in investigator homes. I mean, I'm guessing Christian L'Orange probably has them, right? But the question when you only do 2 or 3 homes is these may not be representative. Like you might think you understand the model and you don't.
Mm-hmm.
And because you've only had a very small number of ideal-ish homes.
Mm-hmm.
And so that was the goal with Epic Homes, is to try to implement the principles on a larger range.
Mm-hmm.
With regard to the previous data, I think so it wouldn't have the delta P measurements, and so it wouldn't serve a certain purpose. But if we were able to have a sufficiently long measurement of delta P where we were more or less confident that we could predict the delta P from weather conditions, then those could be used going toward the past. I think that's not really a part of our project, but part of our project is moving towards being able to say that we have a more explanatory or we're better able to explain, or not yet able to explain, indoor outdoor transport.
Mm-hmm. Okay, that answers my question about the value or utility of historic or data that happened before the delta P measurement was implemented. I think I also share your view that 10 to 15 homes of non-investigator homes should in theory capture a wider range of housing characteristics and in-home behaviors.
Mhm.
And I do think this is a good point to be talking about it because we're in more constant not constant, but more regular communication with the homes that remain in the study, which I said is about 15 to 20 right now. We're scheduling last calibration visits with PM 2.5 sampling for the sensors, and we're, in theory, we're scheduling like a, their final, like we'll tear down, take instruments out. We could ask who would like to, this would be a good point to say, we're coming to a close in terms of data collection for the project that we enrolled you for. We would like to ask if you'd be interested in a new study. And for that, we would need to have a different, a new consent form. It wouldn't be that different, but all of the IRB stuff, we could then have them transfer into that and then leave everything in place.
Mhm.
That's advantageous because leaving things in place is lower burden. And
Yeah,
I would anticipate that
fraction.
there's some fraction of homes that would say yes.
Yeah, I wouldn't count on all of them, but I think even 10 would be fantastic. And I just know how intense it is to keep that real-time monitoring going, to install it and take it down and keep it calibrated. And so part of my motivation is greed, right? It's like, you have this stuff, we should take advantage of it.
Yeah, and I guess what I'm wondering is, if because we could also try to recruit additional home, if the number ends up being too small, we could recruit additional homes. But I think we could start with the homes that are already in the study that still have instrumentation and see what fraction of them say yes to continuing.
Yeah, that would be my thought. When are you scheduling the tear downs? Like, can you give me a sense of the time frame that we're working with?
Within this, like I think our window is until like end of May, since that's when students are available.
Mm,
So
Yeah,
like we're right now, last week, this week, next week, we have one home visit scheduled per week. And that's just for filter-based deployment for a week as a calibration measurement against the PM 2.5 value.
but it would be ideal to add the pressure measurements at that time. Are you I assume you're measuring indoor temperature already and
Yeah.
humidity? Yes, we don't need to add that. And are you measuring outdoor
Yeah.
conditions? Or-
Just the temperature and relative humidity.
Okay.
Well, and it's the Omni or the Aware Omni device. It also has CO2, TVOC, PM 2.5 with a planned tower PMS 5003.
Okay, so you have a wind measurement, but that's probably not
No.
what Dom showed. It could be a little important, but not very. So I think the idea of recruiting additional homes, I appreciate you being open to that, but it feels like the urgent thing right now is decide what we can recruit now. And I don't actually feel like we need, like, if we could get in soon, we wouldn't need to extend beyond May.
Well, so that was my question, is I think what would be attractive is to offer a home, like, can we, are you interested in being enrolled in a new study that builds on what we've been learning from your home? And it would look like this. We would schedule, like we have in the past, we would schedule a visit to instrument some additional measurements. And that would happen within this spring would be ideal, because otherwise I think we are more looking at like, well, summer wouldn't be so bad. Some of these homes started in the summer last year and they were told that the study would last 9 to 12 months. So we're not outside that 12-month window. And even within 40 homes, it's been variable. Some homes are aware of that 12-month window and then have asked, like, are we done? Can you take things down? Yeah. Because usually, to be honest, it's often because of heterogeneous support in the household of enrollment in the study. So, someone's like, my other person is telling me that we need to be done, so. But there are other people that don't notice at all, are unaware, unperturbed in any way. But I think what would be advantageous is to schedule a visit within the fall, say the spring, before the middle or end of May. And sort of get them into that next study by that point in time.
Yeah.
I do think we're at a point with most of our households because of how many touches we've had. We have had 3 or 4, if not a few more, because sensors go down a lot. We've had enough touches that I think offering compensation matters, like early and upfront. I know there was budget for that. We talked about it, I think, at the time of writing, but I think making that clear upfront that this would be an additional study with additional compensation.
Yeah.
And
I
whatever that.
don't have a problem with that. I think the incremental value is pretty large, so. I don't
Yeah.
remember what the budget is in the project, but it will be made to work.
Mhm. The other issue that I guess I feel a little bit embarrassed because I'm like, oh, I should have thought of this when we were writing the proposal, is that the sensors are now 2 years older than when the proposal was written. So we've had 1 or 2 that are out of 120 that are like completely, they seem unrecoverable.
Mhm.
This is why I think commercially available sensors are moving to this model. There's a few that are on this model of like just replacement, like you just send it in and then they say, we'll send you a new one. And that, I think that's smart of them. The
Yes,
other issue that I failed to foresee is that we would have to upgrade the subscription service in order to access the data like we have. Which is annoying.
Yeah.
And solvable and not as overwhelming. Like for 120 devices, that was a pretty big bill to foot for, and we got them to waive. We got Aware to waive some of that fee because the city of Fort Collins purchased these sensors and they sort of rationalized why they should get a
Mhm.
break.
Mhm.
But some of them are reaching their subscription end of life, like we have to re-up the subscription. And I wanted to bring that up because I feel like I've forgotten about that. It's and I apologize. It's still around, it's like $100 per sensor. So it's not for 10, like for 10 homes, it'd be, and 5 sensors, it'd be 5,000. It's not a trivial amount of money. I haven't broached that in my head, like I haven't gotten around it.
Okay. I think what would be good as a next step, it sounds like we do have a window for continuing some of these homes. It might be good for us, you, me, and Dom at least to meet offline. And go through the logistics of exactly what would be needed and maybe even look at it home by home or group by group.
Mhm.
Another thing that I'd like to bring up, and maybe Paul could weigh in here, not all seasons are equal. Some seasons are going to give you more of a signal to play with. On the other hand, I'm kind of curious about what happens in those seasons where there is very little driving force for indoor-outdoor exchange. And so, but we might look at that as a group in terms of house by house and when each one is going to be ending. But this does seem like something we should jump on, and that might mean shifting Dom to installation for a few weeks. And then that also, Dom referred to refinement of the systems. As you know, Ellison, when you go out to do field work, you kind of need to have your package down. And if you're, where we are is not there, right?
Uh-huh.
Like, that currently I can show you the installation of pressure sensors in our home. Here, there's can you see it? There's the manometer, but currently we have had to put it through the window. So the window's all taped up, which is not something that most people would accept. So figuring out something around that. So we probably, even hustling, we probably would not be ready to go for a couple of weeks, but maybe we
I
should
think
just.
we're okay for, I mean, I think given, like, we have 15 to 20 and we're going fairly slow, like, and our plan was through May, so it, like, even if it were really spring that we're talking about, like after spring break, I think it's still probably doable. I think what would matter though is communicating earlier, because we, through my just not being able to manage what I had on my plate, there was a period where we didn't communicate very much with the homes, which more or less is not a huge issue in this study, because there's long periods that they go, like several months of monitoring without a visit from us. But I think we pressed that limit. So I've had somebody that's been, brought on partially onto the project to help with sort of patching up communication, making sure people feel like we know we're there and we're appreciating being there. So we're communicating more regularly, and I think it would be maybe, as we've built back a little bit of trust, I think we could also just message about this study, even if you're not quite ready. Like, I think there are some homes we could get a yes, even if we're like, we're not going to do this for 2 months.
Yeah.
But we are probably getting to the point where we want to be precise or have narrow confidence intervals on when the timing of things are, so that we communicate correctly to households. Because I think we're at risk of them being fed up with me if it's like, well, it'd be approximately a month to 3 months. And they're like, yeah, I don't want to deal with that anymore. So, and I'm sorry, that's just where, that's where
It's a thing that happened, and it's the situation that exists. Paul, you've got your hand up, and I'm going to have to go soon. So let's
Yeah.
wrap this up, but be sure to set another smaller group meeting where we can walk through some of the details here.
Okay.
Yeah, I just wanted to say real quick, having tests done when it gets more mild, Tammy, you're talking about when there's not much driving force, especially in a place like Colorado where you have 30 to 40 degree temperature swings within a 24-hour period. Even if you don't have very much driving force at some point, you're going to have a decent stack effect driving force at other points. So I don't think there's a real problem. Right now, in this time of year, you don't get the almost no driving force. But in the spring you would. The big concern with going into something like the spring is if people want to open their windows. Once they open their windows, none of this holds anymore. It's all nonsense.
But I think that's okay, because I mean, it may be nonsense, and the nonsense is unpredictable in terms of indoor-outdoor exchange. But I also have seen papers where they're like, well, look, we had really high air exchange rate. I don't know, maybe they opened their windows. Whereas I think if you had Delta P, you would know if their windows were open, right?
Yeah,
And so it's a thing that happens. And it's a thing that we have to account for behaviorally. And so I don't have a problem with having some of that. I think if they had windows open all the time, it might be useless.
Right.
But seeing that back and forth might also be interesting.
Mhm.
Okay, Taylor's got a question about IRB, and that's something that I think I will table until the small group meeting. Ellison went through the IRB for her project. And so it would be adding the pressure measurements, but you're right, Taylor, we might need to get a jump on the IRB addition, right? Cool.
Yeah, I think we could amend it. We'd also have to add the funding source, since the project is no longer, like, the funding is finishing this spring
Okay.
from my side. So,
Okay.
but that can be part of an amendment.
Okay. But it's something that we would not want to leave until the last minute.
Yeah, I think we should start on a CSU IRB amendment now. or
Yeah.
Effectively now.
Okay, cool. Thank you, everyone. This is good, and I think it's something to move on. So we'll work toward getting some smaller group meetings scheduled, and then report back to the bigger group about what's going to happen.
Okay. That sounds good to me.
Thank you.
Thank you very much, Tammy. Thanks, Don. Thanks, everyone.